Hello everyone, in this short lesson I want to talk to you about something called scope. It's a pretty simple concept. It just tells us where in the code we can see and use something and often how long that thing lives in our program. So first, what do I mean when I say something? Let's say you're writing code inside a function. What kind of stuff can you access from there? You've got variables, constants, arrays, other functions, right? All of those things have names, or more technically, identifiers, and I'm gonna call all of them entities in this lesson. There are other entities too, like pointers, references, classes, structs. We're not diving into those yet, but we will later on. So back to scope. It's the area of your code where a certain entity is accessible, basically where you can use it without the compiler yelling at you. In this lesson, we'll go over different kinds of scopes using the stuff you already know. This will help you understand C++ better. You'll know when a variable starts and stops existing. If that sounds confusing, don't worry. Once I show you some examples, it'll all make sense. Let's get started. Alright, so I wrote a simple piece of code. In it, there is a variable I created, used for a bit, and that's it. Quick reminder, you can't use a variable before it's been created. In our case, the variable is created on line number 9. Before that, it just doesn't exist. So its scope starts right at line 9 and ends at the closing curly brace. This kind of scope is called local. Why local? Because the variable only exists inside the function where it was created. You can't use it outside the function. It's completely invisible out there. So, whenever you create variables, constants, arrays, or any other objects inside a function, their scope is called local scope. Alright, let's move on to the second example. Remember how we can create variables inside expressions like if, switch, while, do while, and for? In this example, we've got one variable with local scope, just like before. But we also have a variable I, which is created inside the parentheses of a for loop. Its scope starts when it's created and ends when we exit the loop. So before the loop, I doesn't exist yet, and after the loop, it's already gone. That's why we can't access it outside the loop. This kind of scope is called block scope. Why block? Because the for loop has its own block and you can create variables inside it. That block is nested inside the functions block, so it's more limited than local scope. Same thing with the variable b in our example. It's declared inside the loop body and it's created on each iteration. You can't use it before it's created and you can't use it after the loop either. Its lifetime is limited to the loop, so again, block scope. This works the same way for other loops and if statements too. You can declare variables inside them, but their scope is limited to that block, meaning the curly braces of the statement. Now, I also want to tell you about a cool feature from C++ 17. You can actually declare a variable directly inside the condition of if or switch. Why would you do that? Well, a lot of times you only need a variable just for that one condition check. Let's say you want to do a quick calculation for some or get some value. Normally you'd create a variable outside the if, give it a value, and then check it in the condition. But the problem is that variable would still exist after the if, even though you don't need it anymore. That wastes memory and blocks you from using that same variable name later. Before C++ 17, there was a limited version of this. You could write a variable in the condition, check it right away, and that was it. The variable would only live during the if block and get destroyed after, which is nice, but you couldn't write more complex conditions with that approach. With C++ 17, now you can. You first create the variable, add a semicolon, and then write any condition you want. The variable will live just for that if block and be destroyed right after. That's block scope too. Same exact thing works with switch. You can declare a variable in the parentheses, add a semicolon, and then put the expression that gets compared to the case labels. So let's recap. If a variable is created inside a function, it has local scope. If it's inside an if, for, while, switch, or any other statement block, that's block scope. Alright, let's check out the next example. Notice how I've been creating the variable b inside different blocks every time? That's totally fine. The compiler won't throw any errors because those variables don't exist at the same time. One gets created, then destroyed, and then the next one gets created and so on. No overlap, no problem. Now, here's another version of the code. And this one also works. But before I explain it, try to answer this. What do you think will be printed on the screen? The answer is 30. Why? This is where variable shadowing comes in. Shadowing happens when a variable declared in a narrower scope, like a block, has the same name as a variable from a wider scope, like a function or global scope, and in that case, the one in the narrower scope hides the outer one. So while we're inside that inner block, we're only dealing with the inner B, not the one outside. That's just how C++ works. The compiler picks the closest matching variable it can find. Now, even though we're inside a block, we can still access variables from outer scopes if we really want to. To do that, we just add 2 colons before the variable name. That tells the compiler, hey, I want a variable from the global scope, not this inner one. But don't worry if that sounds a bit confusing. We haven't covered global scope yet. We'll get to that a bit later and come back to this example again. Alright, moving on to the next example. You can also create variables as function parameters. These have their own scope, called function parameter scope. It works pretty much the same way as local scope. In this example, check it out. Variable A has function parameter scope. Variable B has local scope. Variable C has block scope. Nothing too crazy here. Just keep in mind that the scope of a function parameter is limited to the function it was declared in. You can't use it outside the function, just like any other local variable. Okay, let's look at the next example. You can also create variables outside of functions. When you do that, those variables get created when the program starts, and they stick around until the program ends. We'll talk more in another lesson about where these variables live in memory and why they're sometimes called static, but for now, let's focus on their scope. This is called global scope, and it's pretty simple. A global variable can be used anywhere, inside blocks, functions, and even from other files. That's why they're called global variables. In my setup, I've made global variables show up in brown just to make them easier to spot. You might have noticed that cout is also brown. That's because it's a global variable too. We'll learn more about cout later, but for now, just think of it as a tool to print stuff to the screen. So in this example, I'm using my global variable a few different times from different functions. Sometimes I'm reading its value, sometimes I'm changing it. Why you probably shouldn't rely on global variables too much, we'll talk about that in a separate lesson soon. Now, let's go back to example number 3. Why is there an error here? Well, the double colons mean go to the global scope, but in this case the outer variable isn't global, it's in local scope, which means the double colons won't find it. If we move that variable to the global scope, though, everything works just fine. Alright, now let's move on to the final example. Did you know you can actually create your own custom scope in C++? Yeah, but it has to be inside a function, but all you need is a pair of curly braces. This is called a statement scope. Inside that scope, you can write pretty much anything you'd normally put in a function, including variables. And any variable you create in there will only live inside those braces. Once the block finishes running, the variable gets destroyed. This gives you precise control over when a variable is created and destroyed, which can help you write cleaner, more efficient code. So, when is this actually useful? One good example is when you want to declare variables inside case labels in a switch statement. Now, maybe you forgot, but in C++, case and default don't create their own scopes. They're just labels, not code blocks, so any code inside them shares the same scope as the rest of the switch. That's why, in this first example, the compiler complains because the code between case 1 and case 2 gets mixed, like you're declaring a variable halfway through an active block. And C++ doesn't like it, but if you wrap your variable declarations in statement scopes, everything works fine. Just a heads up, Visual Studio sometimes formats this kind of code poorly, so you'll either have to live with the ugly indentation or fix it manually every time. Now, one last thing. Remember how the variable in a for loop has block scope? Let's say we write a basic for loop. Easy to read, nothing special. But you could also rewrite it as a while loop now that you understand scopes better. So here's how that would look. We declare the counter before the loop, use a while, and manually increment it inside. It works the same way, but honestly, don't write code like this. It looks messy, and the regular for loop is just way more readable. Alright, so there are other types of scopes too, but they're tied to things you haven't learned yet. For example, later on, you'll be able to create classes, and classes have their own scopes. Same goes for structs, enums, namespaces, and even separate files. We'll talk about all of that when the time comes. But for now, here's the main idea you should remember. Most of the time, a pair of curly braces defines a scope. Of course, there are exceptions. For example, when you create an array using list initialization, you also use curly braces, but that's not a scope, it's just syntax for setting values. So now you've got a better understanding of how C++ works. There's this concept of scope, which simply means where in your code a certain object is visible, and if it's visible, you can use it. One last example. Most functions in C++ have global scope by default. That's why you can call them from anywhere in your project. And that's the end of this lesson. Thanks so much for watching. I hope you found it helpful and maybe even enjoyed it. If you did, you can show your support by giving this video a like, leaving a comment down below, subscribing to the channel if you haven't already, or even donating via the link in the description. You can also become a channel member to unlock access to all the practical lessons, where you will be able to practice and solidify everything you've learned. All of that really helps grow the channel and keeps me motivated to keep making more lessons like this. Wishing you smooth and enjoyable learning, take care, and see you the next time.